So record, there we go. All right, so we're moving on from just single linear functions and how to graph those and such, but to something called systems of linear equations or linear functions. And what a system is just two or more related equations, all right? They can be linear, and that's what we're going to focus on. When you get into higher level math, you'll see systems that include not only linear functions, but quadratic functions and things like that. All right, so we've talked about different types of functions, and linear functions are the ones that make lines when we graph them. So for systems, what we're looking at is two or more related equations, all right, with the same input, usually x, and the same output, usually y, all right? So if they use different variables, let's say they used t instead of x for the input variable, it would be t in both equations, all right? A solution to a system of linear equations is simply just a point, an xy value, okay, an ordered pair as it says here, that makes both equations, and what the word we want here is true, all right? Remember, we have different types of equations. We have true equations, ones that are actually true. We have false equations, okay, ones that are not true. So a true equation would say like 5 equals 5. Well, a false equation would say 5 equals 0, okay? So we're looking for equations that actually make them true. The third type of equation that we have is an open sentence equation, and that's anything with a variable. So what we are going to do today is we're going to look at how do we tell whether or not the solution that we got, okay, and we'll look at different ways to find solutions later on in this unit, but to start with, we want to just be able to check our solutions, all right? So to check our solutions, we want to be able to do that by simply replacing the x and y value in the equations that were given for that system, okay? So the system will be two equations that are related in some way, and usually the relation is simply just that they have the same variables, okay? So in this case, these are related equations because they both have x, y, all right? And so this would be our system. And we want to find, is there a solution to this system? And some systems won't have solutions, and we'll look at that later as well, all right? But for right now, we just want to see if this point of 4, 9 works in this system. And some systems have this format. This is slope-intercept form. Y equals mx plus b, and y equals mx plus b. All right, others have standard form equations, all right? Ax plus by equals c. The other option is that they have a mixture, one standard form, one slope-intercept. So I'll show you how to use both of these equations to check our solution. And so whether you have two of the same type, like these examples, or one of each type, you still should be able to do it in that situation, okay? So first thing we're going to look at is how do we do this with a slope-intercept form equation. First thing we want to make sure is that we understand that this point that they're giving us is an x, y value, okay? So this point of 4, 9 is an x, y coordinate point, and we will simply, to check this, we want to see if this equation is true if we replace x with 4 and y with 9. Will it say 9 equals 9 in the end is what we want to find out. Same thing over here. We'll replace x with 4 and y with 9 and see if it's actually a true equation. If it doesn't come out as a true equation, if the numbers are not equal to each other at the end, then we would simply say that no, this is not the solution to this system, okay? And there's only one point that actually makes this work. So we could pick an infinite amount of points, except for that one that would be false. There's only one that actually makes this true. So let's try that out with each of these equations. So we're going to replace, and I'll zoom in a little bit here on it. Just scoot that down. All right, scoot this over so we get a little bit. So we're going to simply replace x with 4 all right? So we're gonna take this in y with 9. So I'll start over here and replace y with the 9 from that point, and I will replace the x with the 4 from the point and keep everything else. So this is 2 times x, which means we're gonna say 2 times 4, right? And the plus 1 is still part of that equation. So now we're just gonna simplify this side to see if it equals 9. So over here, this would become 2 times 4 is 8, plus that 1, that will eventually equal 9. So if we continue that down, right, that is a true equation. So that is true, okay? What we need is both equations to be true. So we'll come over here and do the same thing. We'll replace y with 9 and x with 4. Well, x doesn't have a coefficient, so we're just going to say 4 plus 5. So that's also equal to 9. So that is true. So the answer, is this solution a solution to the system, would be yes. Okay, and if I asked you why, you would say because both equations are true when I plug in those values. Okay, so do we have any questions on how to check a solution in a slope-intercept form equation? All right, I don't see any hands at this point, so we'll go take a look at the second example here, and I'll move this down a little bit. Okay, so example 2 is, let's see if I can get this to focus a little bit better. All right, there we go. So is this solution of 6, 7, or the point, is that a solution to the system of equations? Does it make both equations true? All right, and if at any time you plug in a value and it doesn't work in the first equation, there's no point in checking it in the second, okay? Because if it doesn't make the first equation true, then it doesn't matter if it makes the second one true. It has to make both true, okay? So we're gonna simply, again, this is an x, y value, so we're gonna replace x with 6 and y with 7, and same thing over here, x with 6 and y with 7. So first thing I want to do is replace. So I'm going to say 16 times 6, so 16x means 16 times x, so it would be 16 times 7, plus 3 times y. Well, y is, or 16 times 6, I should say, and 3 times 7. Okay, and does that equal 2? I think we probably can tell right away that the answer to this is that this is going to come out false, okay? So 16 times 6 is a certainly a much bigger number, right? It's 96 if we did that on the calculator or in our head. And then this is 21, all right? 96 plus 21 does not equal 2. I mean, we don't even have to finish that out. Even just doing 96 and knowing we're going to add something should have told us that that was going to be false. So this one is false. So it won't matter what happens in this one, but if you had done this one first because you thought, oh, well, this is an easier problem to do the multiplication, you could have done this one as well. All right, replace x with 6 and y with 7. And once again, 8 times 6 is 48, plus 7 is not going to equal 16, okay? So that one would have been false as well. They're both false. It wouldn't have mattered if one had been true. So the answer to this is a no, okay? This is not a solution to that system of equations. And again, there's only one point that would have made that true, possibly, okay? So pretty much what you're going to be doing on the IXL today is that. They're going to be giving you 2 equations, all right? And you're simply going to be replacing x and y, evaluating one side, okay? So because in both of these types of equations, whether it's standard form, you've got a number by itself over here once you replace y, or sorry, in slope-intercept form, you got a number by itself when you replace y. In standard form, you've already got a number by itself. So all you really need to do is simplify, in the case of slope-intercept form, the mx plus b part, okay? And then over here, you would need to simplify the ax plus by part. Okay, so on the slope-intercept form, you're simplifying the right side of the equation. In standard form, you're simplifying the left side of the equation and seeing if they are equal to the numbers on the other side. All right, questions on how to check our solutions for a system. All right, well, let's take a look at the IXL section then real quick. So we'll stop sharing that and go to our other screen here. So we'll go to this, and let's go back over to our IXL. So again, what we're looking at on our IXL is this AA1, all right? And if you don't necessarily want to go straight to there, oops, that's not what I wanted. I'm off that. We want to go to, come on, go back to IXL. In the, we would have the link on EDSB as well. So you can just get to it from there. There's a hyperlink on the EDSB page. So this one, we will go ahead and click on it and open it up. So this is our AA1. And as you can see, they will be giving you a similar to the same types of questions we just went over, right? A solution and either two standard form equations like this, all right? Possibility exists that they give you, we'll just jump ahead. You'll see standard form equations. So the numbers will get a little bit bigger, but the difficulty or process doesn't really change, okay? So make sure to use your calculators here. And all of these, they're showing me our standard form. I don't necessarily want standard form. Let's see, so, and they're all standard form examples for some reason here. All right, there we go. So some slope intercepts. So whichever it is that you're getting, we're just going to plug in Y for Y, plug in X for X, and evaluate each one. All right, any questions before we split into groups at all for work here? Ms. Carey, did you have any questions about the IXL section or the?
Nope. Nope, I'm good.
Okay, so we'll go ahead and split into a couple of groups working on AA1. If you've already finished this up, or if you want to work on your own, that's fine. You can do that. Just keep in mind that we do have office hours today from, looks like Toby's got hand up. Let me go over to him real quick, actually.
I have a question.
Yes.
How did you just jump like 30%? And can you tell me how to do that so I can do that?
It's a feature on the teacher end of things, so you can't. But it's a good try, Toby. All right, so let's split up into some groups here. So we'll do 2 rooms. And let's see, Miss Carey, it looks like we've got 1, 2, 3, 4, 5 people for your room today.
Okay.
All right. And I'll take the rest here. All right, rooms are going to be open. We'll jump in there in a minute.
I'm good. We're good now. Are we good? I need help. How do I do this one?
Okay,
No
this is like that first example, right? You're going to take the y value of 10.
Okay.
Place y in both equations with that number.
So we do 1 plus 7?
Yep, and then you're going to replace x with 1 in each case. So
Okay. So this would
just
be
in that
solution.
first one, does 1 plus 7 equal 10?
No.
All right, so if it's a no on any of them, it's a no for the whole thing.
All right, thanks.
Yep. All right, so let's take a look. So notice how in that problem you have, in both equations you have third, right? One's a negative 1/3, but the other's a positive 1/3.
Mm-hmm.
And what they are going to give you for the most part on these is when they give you a fraction, they're going to give you a number for x that's going to erase that fraction. Okay.
Mm-hmm.
So what I mean by that is, see how the x value is -3?
Mm-hmm.
If you remember, -3 is really going to be -3 over 1, right? When we multiply it by that fraction of -1/3 or 1/3. So
Mm-hmm.
when we do multiplication of two fractions, we can cross simplify. So 3 will actually cross simplify, right? Basically becoming ones. So when we cross simplify that first one, okay, what you have left after cross simplification would be just the -1, that's the top part of the fraction, and then also a -1 for that -3 would become a -1 after we cross simplify. Okay, so we would have a -1 times -1 on the top, and the bottom would just be 1 and 1. Okay, so really what we're dealing with is that 3 kind of get canceled out. Okay, and all we're left with is the numerator, and then in this case, a -1 would replace the -3. Okay, so it'd be -1 times -1 in that first one. So would -1 times -1, what would that equal?
1.
1, and then plus 7 would equal,
8.
right. So does that 8 equal -2 that the y is equal to?
No.
All right, so if that's a no, then the whole thing's a no. So it doesn't really matter what happens in the second equation.
Mhm.
All right, so most of the time they're going to give you fractions, and the value for x should eliminate the fraction and just give you some sort of integer or whole number value.